Okay. Yeah. So let me restart. So what I was saying is that let's talk about interfaces. What is an interface? So interface has multiple meaning in multiple aspect, but in software engineering, we typically use interface in the sense that we want to define what are the functions that we want. What are the functions? There are two things that an object has. An object can be anything. It can be an object in object-oriented programming languages, or any data type or anything. So what we want is that we want to define what are the things it can do and what are the things it has. By has, I mean what are its properties. Typically we store it in a struct, in some variables or anything, the properties that it has. And then there is what are the things it can do. Like for example, I was giving, let's say we want to create a robot of a dog. So now if we, let's say, start discussing in a room, uh, we have been tasked that we have to create a robot of a dog. Now we start discussing what are the things it can do. So somebody says that, yeah, it can walk. Somebody says it can bark, uh, things like that. So, and then we try to define what are the things it has. So then somebody says that it has 4 legs. Somebody says it has 2 eyes. So these are its properties. So before we define what are the things it can do, I mean, exactly like how it can walk, like does it have to walk on 2 legs, walk on 4 legs, those nuances comes later. But we first define that it can walk. Then we define how can it work. So then we define the interface. Okay. And then we can define it on the basis of a property. So if I just take an example, let's say create is the screen size all right? Okay, I hope it is. It will give you that. Yeah. So first we define struct. Like it has legs, which is integer, eyes, which is integer, and things like that. Then we can create a new constructor for it. Acha, is anybody having any question till now? Like, is the definition of interface and property clear?
Yes.
Yes, it's
Subro?
yes. Yes.
Yeah. So basically, that's the definition. So now, when we are, let's say, tasked with saying that two things an object has. So let's say we create an object called dog. So now there are two things. What are its properties? What are its functions? So now, and in Golang, what we typically do is that, let's say dog is the data type, the interface that it can implement, or the general interface that it can implement, we typically add an ER to it. So let's say if the type is dog, then we can create an interface called dogger. Okay, it does not make any sense, but typically this is how we do. Okay, like for string object, we have an interface called stringer. So yeah, that's the convention, but yeah, you can name it anything, but it has to make sense. Now what it can do is that we say that it can walk. Now walk can take the legs, how many legs it has, and typically it returns an error. So let's say the dog can have some issue with its leg, and things like that. But then I can say that it can bark. Then what it typically is required to bark? Required to bark is mouth. Mouth can be boolean, like there can be an issue with the mouth or not, because it's a one object, right? Typically people have only one mouth. So then it can return an error, or it can also, in this case, let's say it can also return a string, what it is going to bark, and if there is an error. Okay, so now I say, when we are discussing that ठीक है भाई, हमने struct बनाया है, क्या क्या properties है उसके, or what are the things it can do. Now we have to define. Okay, then we can say that type dog implements it. So when we define, so let's say we now we have to create an object of type dog. To create an object, we can also create it in a very simple way, like we can create a new struct and then fill its field, but typically we use a constructor. Okay, and constructor is like new, then the object name, new dog. Then we can provide its properties, like we will typically like to provide its legs, then eyes, both are going to be of type integer. And once it is done, we will return a pointer to type dog. Then so here, if you want to do any operation, we can do it here. Just give me a moment, guys. Sorry, can you guys hear me now?
Yes.
So this is called a constructor. Languages like Java and all, they typically have it inbuilt, but we can define it this way. This is a very simple thing. I will also tell you what are the benefits of having a constructor rather than defining it as it is. In this way, when we create a new dog, we can create an interface, we can create a new dog type object. Now we have to define the Dogger interface. But like in Java, we have to say a function or an object implements an interface, implements. In Golang, we don't have to write implements. We just have to define the function. And if it matches the function type, it automatically becomes of that type. I will explain it a bit more in some time.
बहुत मुश्किल है
Hello.
आप एक दूसरे का फायदा उठाने लगते हैं
Hello. Hi, Alex. Hello. Uh, Hi, Alex. So hope you can resume from here. We were just discussing like what is a simple interface, and we are just trying to implement it just to show how it is implemented and how it can be interchangeably used. So now if we create a function of, let's say, d, which is a pointer to dog, then we just have to say walk. It should take the nature has to be same. Now what we can just do here is that is define it here. Anything, we are just printing it. The simplest operation. Just a simple print operation. And obviously there can be no error here, so we just return nil. Anybody has any question in the meantime? This is a very simple part, so just wanted to be sure. Appeal.
No, it's fine.
Okay. So here I will show you what is the property that we typically use for repository pattern. That is the next thing that we are going to come next. Okay, why is it saying that wrong type bool? What is the type for boolean in Golang? Any idea? Anybody? I think ampersand B.
It is bool only.
B only, right?
Yes.
So I have provided it this, but why is it saying that it is wrong type? No worries. So we can maybe change it. So this is just an example to show it can be anything. Now the property that we use for repository pattern is we say we will use an implementation, an object of type dogger. Okay. But when we assign it a type, we will use dog type, not dogger. Number of legs is 4, number of eyes is 2. Okay. And then what we will do is we can call dog dot bark. We will use dog dot walk. Actually, walks is not it is not good to have number of legs because in the properties we have already defined it. So we will remove it from here because otherwise we are not using the inherent properties. We are always using what is the argument to it, which is not required. But here I will it will also show like why you cannot use argument this way and why we have used an constructor. Can anybody tell at this point, like, will it work or not? D dot legs, will it work if I use it here? Will Subro, can anybody say if I use D dot legs here, will it work or not? Because D has the property.
Yes, sir. I
Alex
think
says it will. Alex says it will. Kapil,
Yes, I think it will work.
it will work. Kapil,
Yes.
Subro,
Mm-mm.
Subro, what do you think? Will it work or not?
I'm confused basically. I don't think it will work.
Will it work?
But
Yeah. Why? Why do you think it will not work?
because it is a pointed type, right?
So,
Mm,
so what?
let me just see.
Okay, no worries. We will see. Karthik, Kapil, why do you think it will work?
Because we have called it a constructor, new door,
Mhm.
and it now it has a value of legs and eyes, and
Mhm.
from that after that we call that dog dot bark and dog dot walk. So
And Alex, what do you think? Why will it work? Same reason as Kapil? And Abhinav, any comment you would like to add?
No, sir.
Yeah, I think it will work because in the new dog function we are returning the dog, the pointer type dog, right? So we are defining it here. So if we do d dot legs, it should return the value of legs.
Let's see. And what happened to dog.bark? It just returned, so we should have printed it. Print it here. The only thing that you are supposed to, because I'm pretty sure interfaces is clear to everyone. Only thing I want you guys to understand here is that dog type, we created it, we initialized it as dogger. Okay, it is not type dog, it is type dogger, and then we assigned a new dog to it. Yeah? So what it returns, it returns a pointer to dog. It doesn't return dog type or anything or dogger type. It returns a pointer to dog type. But the assignment worked fine, no error. Both are different types. One is an interface, one is a struct, but it worked. This is the only power that we are going to talk about. Is everybody clear with this part? Kapil, why do you think it worked? Like new dog returns a type pointed to dog, and dog is a struct, as we can see. So why this assignment worked? What do you think? Line 32. Kapil,
Yes, yes, and
you can ask questions. I mean, it's fine. I mean, it's a session where we discuss, right? It's a session for
yes,
discussion and learning.
yes. So here, we create the struct of dog,
Hmm.
and they using the new dog by using the constructor new dog, we return the type of dog only,
Mhm.
and we store it in the dogger.
Hmm.
So I think how that will be like clear inside the compare that how it compare that new dog and the dogger has the
No, what
similar
I'm
type.
saying is that, as you can see, this dog, this line is of type dogger. We declared it, which is an interface. But new dog returns a pointer to dog struct, which is a
Yeah.
different thing. But this assignment worked. So let's say if we created a dog of type, let's say int, will it work? Now, if we try to run it, it is not working, right? Why is that? Both are different type. Dog here it is of type int, and here it is of type dog. Who can answer? Kapil, do you think you can answer or no?
No, like I don't think so.
Okay. Alex, Abhinav, Alex, can you talk? Function receivers are contain the dog type. So, I mean, I think you are in the right direction, Alex. Abhinav, Shubhro, would you like to explain? line 32. Subro?
No.
Talking about this is your type. Yeah, that's right. Yeah, I get you, Alex. But what does it mean? Like you're saying, data type receiver type is there, so that's why it is working. So what does it mean? Like, what is the meaning of this? This pointer receiver. What are you trying to say? I'm not understanding. Okay, so that means that when I created this dog type, a dog type struct, and then so this means whenever a function references that struct. Alex, I still don't understand what you're trying to say. You should use better words. So the thing is, whenever a function has a reference to a object, and then there is a function corresponding to it, it means that B is of type dog implements this function. Okay, and when this D, the dog type, implements walk function, which is similar to this function of this interface, and then of the bark function, then it means that this dog type satisfied both of the requirements that this interface has. So this interface says anybody who can walk in this way and bark in this way is same as me. The dogger is an interface, has two functions. This dog type, which is at the top, this, since it defined both of the functions, now we can say dog type and dogger interface both are same because it has implemented both of them. It had two requirements, and this dog type satisfied both the requirements, and it did the implementation in its own way. Tomorrow somebody else can also do the same thing. And hence we can say this dog type and dogger interface both are same. That's why this line 33 worked. Understood?
Yes, understood.
Yes, sir.
Yes.
Kapil? Abhinav? So I
Yes, sir.
think it's a very basic idea, and I was a bit surprised to understand that this clarity was not there. So I think I should break this session here and maybe talk about repository pattern tomorrow. Because until unless this you can internalize and understand it very clearly, it is going to be difficult to go to repository pattern because it uses the same idea. So now what I just explained is anybody who satisfies both these types will become of type dogger, and dog type satisfied it. Now we can say anybody who satisfies it will become of the same type. Now we can say that type I don't know who else can bark. Maybe it's not a lot of difference, but let's say I'll use puppy. And it can be any type, it doesn't have to be struct. We can create it of type string, but it should have legs, right, in order to implement the walk feature. So it cannot be a string anymore. It can be a, let's say it can be an integer. We created it, which is not right. Semantically, it doesn't sound good. because puppy is an object which has properties like we define with dog. It has legs, it has eyes. What it has, puppy, if we create it as type int, we can definitely implement it, but it doesn't. It is not semantically right because it is not has puppy. Puppy cannot be an int. This created a type struct, and then it can have same thing. It can have legs, which is of type int. Again, we can create a. So let's say we are not creating a constructor for it. We just have to implement it. For that, we can just do. I think so. Vim has a very good property in which what I did is that on top of it, I just did go impl implement this Docker interface and it implemented it. Okay, it created a basic implementation of it. Now we have to create it. So walk also, what we can do is that same thing. P dot legs, returning no error. And for work also same thing. We can use the same line as this. Instead of dog, I created a puppy. Now what we can do is that we can, instead of dog type, we can create a new puppy implementation, and this can be of this form. Like I was saying, we did not create a constructor, but we are doing it this way. This is also one type, but constructor has some benefits which we can talk later. Now let's say dog only. We create a var dog of type dogger. Instead of this, let's say we create a var dog of type dogger. And here, instead of this puppy implementation, sorry, previous dog implementation, we will use dog, but here we will create a puppy of this type. Now, what do you think? It will work or not? Kapil, Subro, what do you think? It will work? Earlier, we were using a same thing. This line was same, but here, instead of creating a new dog, we are assigning a type of puppy. Will it work?
Yes, it should work because both of the functions are satisfied here.
For puppy type.
Yes.
Kapil?
Yes. It's good.
And yes, it works. Okay, that's the idea, that we will always be. So this is the main takeaway. Understand it for repository pattern, especially Kapil, you understand. Idea is we have always created a dependency. This dog type is dependent on dogger interface and not puppy struct or dog struct. Okay, so when required, we can create and assign a type of puppy, or when required, we can create and assign a type of dog. and all the other code will work as it is. If instead of this line, I would have created, this is the main takeaway for the session on repository pattern, that if we create a new type of this thing, so we just have to create this thing and it will work as just as it is. No difference in code. And even puppy will walk differently, right? The way it walks is different, the way it barks is different. So we can create totally make the implementation different, ekdam different. But there are a few properties which it will always have, right? The pup. So let's say instead of puppy, we could have created, let's say bark is not a function, just walk. So everybody has a different way of walking. Somebody walks on 4 legs, somebody walks on 2 legs, and things like that. So if we would have created just a type walk, then we could have covered lots of different types of entities. Like for humans also this was applicable. For any object, it would have been applicable. Okay.
So this is the way uh, the interface only allows us to actually abstract it, right? And
Abstract, yes.
inheritance has been used here. So we are inheriting the properties of a parent and then just abstracting it using the interface method.
Where are we inheriting? What are
So
we inheriting?
the types here, like the walk, bark, these types, we are inheriting it.
Who inherited what?
No, we have defined puppy here. Yeah, nothing. We have inherited nothing here.
No, we haven't inherited it yet.
Yes, yes,
So what
yes.
we can do is that, let's say we
We can
create
also inherit it, right? We can, if we have to use both of those methods from dog to puppy, then we don't have to define this puppy struct here, right?
no, we defined the puppy struct.
If we have if we have to inherit a property from dog,
Huh.
so is it that we have to define this struct again for puppy if we have to use the same properties of a dog?
No, it's a good question. We can inherit, but here we haven't inherited. Like let's say if we create a type, let's say human struct. So here we can just create a, we can just say dogger, and then we can create all the different functions that it can have. So then what it did is that it inherited a few properties and then it has extended it. So it doesn't have to be this way. Just wait a second. There is a different syntax for inheritance. So in inheritance, what we do is that we say that human type or human interface can have everything that dog has, but on top of it, it can write as well. So now you also have to define walk and bark, but I'm saying that it has both the properties. Human type has both the properties, and on top of it, it can write. It has inherited the properties of dog, and then it has extended it. So it is saying, so what this means, so in Golang, there is no concept of inheritance, there is a concept of composition. Composition means you can inherit few properties and on top of it, you can extend it, but not edit it. The existing properties you cannot change, but you can extend it, have more things on top of it. Okay. And existing things you can always define it separately, like since it says that it inherits dogger interface, so it will be able to walk, it will be able to bark, and on top of it, whenever we define human interface, you will also have to do Implement what? What extra function?
Right.
Right, exactly. So you
So
have to.
I have one question here.
Hmm,
So if this dogger type has, let's say it has legs and bark, right? So
hmm,
I only want to use one of those two. Okay, so let's say I
hmm.
want to use legs only. So there are, let's say there are five properties there. I use three, right? In
Uh,
that case, we have to define those three again. So in that case, we can't use that dogger, right?
yeah. So that's the thing. Properties can vary. So puppy struct has only one property, but dog struct has two properties. But still, both were working, right? So properties can be different. So like let's say a snake and a crocodile, both are reptile. So function is same, but properties are different, right? Like crocodile has two legs, has two things. So that's the thing. So you have to think about natural things surrounding you. So so properties can vary, but the function will be same. So it is extending basically whenever you then define human interface, you will have to define the walk and bark also, and on top of it you have to write bark, and you can define it your way. Like inside bark you can say, I mean this is not good example, but inside bark you can say sorry I cannot bark, because humans cannot bark. So now, so let's say if we have created, since it has one more property, right? So this is a different topic, by the way, we should not discuss maybe, but it's a good opportunity. So what I'm saying is that let's say if dog were not of type dogger interface and it were of type humaner, I mean it should be ER. Human is the type and ER is the interface. So now if we do, can it work? If not, why? Why is it not working? It has all the properties of Dogger
but
interface.
but we have to write the function for write.
Yeah,
Yes,
I
sir.
mean you have to
Right.
implement interface.
Yes, yes,
You have to define right. Since it
yes.
is not defined, that's why it is not working. Dog does not implement humaner missing method right. Okay. Any doubts, Kapil?
No, I'll just so clear.
Yeah. But the puppy type, so if we but in the same dog type, if we also define a type of right, and we write anything here. So now this is returning, it should not return. So now the same thing, it should not be explained here. It can be now the same object that it was here, now the same dog type. Inside main, we didn't change anything. Now you see the same thing is working. Why? Because we just defined the right type for it. So the idea is same. This is the only one takeaway for the next level, which is the repository pattern, that we create dependency on interface. We create dependency on interface always. That is the one line takeaway. And why? Can anybody say why? Why we always create dependency on interface and not a particular type, like not not dog or puppy type, an interface. So I'm saying the main takeaway for repository pattern is that we will always create dependency on interface. Like what I mean by dependency is that where dog is of type humaner, right? So dog has to be of a type humaner. So this has to be you have to be of type humaner. This means dependency. So like I say, that Kapil, you have to know this, then only you will get a job. So I have created a dependency that if you cannot do this, you will not get the job. So here what it means is that I have created a dependency, like now you have to. So in line 54, we have created a dependency that dog has to be of a type. So when there is a dependency, I am saying the dependency should be on an interface. Okay. Now when I've said that it has to be an interface always, now tell me, Kapil, why do we create a dependency on an interface?
So like if you see that in the our code, like if we use the sometime Redis or Postgres, so we can change the logic of that only. We don't have to change the uh, main logic like inside the here the main function. We
Right,
just have to, yeah,
right. So I will, uh, yeah, I will just use better words for it. So the thing is, the logic is same, but what we are saying is that we are changing the implementation. Like Dogger
exactly.
interface or human interface is still the same, but the way it is implemented, I mean, this function, this is an implementation. This function is an implementation. All of these are implementation, which can vary. Like all the things can vary. So this can be anything. Like this implementation can be anything, like whatever. So function is still same bark, and here also function is still same bark, but the implementation is different. So in one line, if we say what is the meaning, the meaning is that we have abstracted the implementation. And abstraction means we don't want to know how you have implemented it. This line says that we want to do abstraction. Abstraction means what? Abstraction means hiding the unnecessary information.
Actually, we are writing the business logic in the implementation, and we are not showing it.
No. Business logic, yeah, you can say it this way. A business logic also falls in this thing. So what we are typically trying to say is that I don't want to know how you are doing it. I want to know what you are doing. So I want to know that I want to create a dog type, then I want to make it bark and I want to make it walk. If it cannot walk, if it cannot bark, I am not going to buy the dog. But how it is walking, how it is barking, I don't want to know. All the dogs can walk differently, bark differently, right? And you can always change dogs, you can always use different, buy a new one, buy a different one, and all those things. But the thing is that it should be able to do these things. That is the thing, that it should be, this line says whatever dog I purchase, it should be able to walk, it should be able to bark. This line says that. It is a dependency. But the dependency we created on an interface. And then we are saying how it is implemented, it is irrelevant. It can be done in any way. This is called abstraction. I don't want to know how it works. I don't want to know how it barks. I just want it to bark and I want it to walk. Then it can do it in another way. Then we can always use any different type here. We can sometimes, like Kapil just said, now let's say we are using Postgres, but we are seeing Postgres is not good. Redis is faster, and we thought that it will be using a lot more RAM, but it is not using a lot of RAM. It is fine. It is able to work. It is able to do this thing. Now it should work. Let's see. Actually, we changed the implementation, right? Has
The right function we
Now just we change the implementation. We used a different type. Now we are using Redis, but still it works. Okay, so that is the funda. Understood?
Yes.
Anybody has any question? Kapil, you understand the main point, right? The main point is that dependency should always be on an interface because we want to abstract. The only.
Yes.
Okay, Abhinav, any question?
Sir.
Okay. So now instead of this, if we created a human type, this is not going to work because it does not implement that. So this is called inheritance. We inherited the features of Dogger, and then on top of it, it can write as well. So this is called composition. Inheritance has lots of problems, so composition is a better form. Golang uses composition. It has all the properties of it. It composed. Okay. Subro, any questions?
No questions now.
Okay. So we will do a different session later, and then we can explain. Okay.
Yes.
Okay. If it is done, then we can wrap it up for the day.
Yes.
Bye, everyone.
Okay. Bye, guys.
All good.
Bye. Have a good day.